Hello all, welcome to the day 58 of the daily case study series for CBSE grade 12. The question goes like this. The derivative of the velocity function v of t with respect to time t gives us the acceleration of the object. This can be written as dv by dt equal to a of t in meter per second square. The derivative of the displacement function x of t with respect to time gives us the velocity of the object. This can be written as dx by dt is equal to v of t in meter per second. A car is moving at a constant velocity of 15 meter per second. It starts decelerating when it is about to reach its destination with acceleration a of t equal to minus t by 3 meter per second square, where t is the time in seconds for which it decelerated before coming to rest. Suppose a velocity function v of t is given. If we differentiate this with respect to time, we get dv by dt, which is nothing but the acceleration function. Since differentiation and integration are reverse process, if we integrate this a of t with respect to time, we get back the velocity function. So if we have a displacement function x of t, if we differentiate this displacement function with respect to time, we get velocity. This is nothing but dx by dt. Again, if this velocity function is integrated with respect to time, we get back displacement function. So with this concept, we will go ahead answering this question. First question, find the velocity function of the car after it started decelerating. Show your steps. The question says, a car is moving at a constant velocity of 15 meter per second. That is, this is the initial velocity. Say at time t equal to 0. It starts decelerating when it is about to reach its destination with acceleration a of t equal to minus t by 3 meter per second square. At time t, velocity becomes 0. We have been given with the acceleration function. Let's take that acceleration function. A of t is equal to minus t by 3 meter per second square. The question is asking us to figure out the velocity function. So we are starting with the acceleration, which means we have to integrate this a of t to get v of t. V of t is equal to integral a of t dt. That is integral minus t by 3 dt, which gives us minus 1 by 3 integral t dt. Integrating t, we get minus 1 by 3 times t square by 2 plus c, where c is an arbitrary constant. So v of t is equal to minus t square by 6 plus c. This is the general solution. At t equal to 0, the velocity is 15 meter per second. At t equal to 0, velocity is 15 meter per second. That is, the initial velocity is 15 meter per second. Substituting this, we get 15 equal to 0 plus c, that is c is 15. Now putting this arbitrary constant 15 into the general solution, we get v of t is equal to minus t square by 6 plus 15. So this is the answer for the question 1. Question 2, find the time it takes the car to stop after it starts decelerating. We have to figure out how much time it has taken for the car to come to a stop state. That is, the final velocity is 0. So let's put v equal to 0 in this particular solution. So 0 equal to minus t square by 6 plus 15. T square by 6 equal to 15. T square is 90. T is equal to plus or minus 3 root 10 seconds. Ignoring the negative, we take T as 3 root 10 seconds. This is the answer for the question 2. Question 3. Find the displacement function of the car. So to get the displacement function, we have to integrate the velocity function. Let's take the velocity function v of t, which is minus t square by 6 plus 15. X of t is integral v of t dt, which is integral minus t square by 6 plus 15, which gives minus t cube by 18 plus 15t plus the arbitrary constant, which is x of t. When t is 0, x is 0. Substituting this in the equation x of t, we get 0 equal to the terms minus t cube by 18 and 15t becomes 0. So we get c as 0. Putting the value of c in x of t becomes minus t cube by 18 plus 15t. The next part in the question says, calculate its displacement from the moment it starts decelerating till it stops. That is, we have to figure out the distance that has been covered in the time duration 3 root 10, which is minus 3 root 10 the whole cube by 18 plus 15 times 3 root 10, which can be written as minus 3 root 10 into 3 root 10 into 3 root 10 by 18 plus 45 root 10, which gives minus 27 times 10 root 10 by 18 plus 45 root 10. On simplifying, we get minus 15 root 10 plus 45 root 10, which is 30 root 10 meters. And this is the distance traveled before the car came to a rest. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos. See you all with another case study question tomorrow.